Imagine an explosion so powerful that for a few brief moments it outshines an entire galaxy. A force so intense that it can create chemical elements essential for life itself. We're talking about supernovas, the most massive explosions ever witnessed in the universe. Today, we'll discover how these spectacular stellar deaths have shaped the cosmos as we know it, and even created the very atoms that form our own bodies. Picture this, a star much larger than our sun, reaching the end of its life in the most dramatic fashion possible. In its final moments, this dying star releases more energy in seconds than our sun will produce in its entire lifetime. These cosmic explosions don't just put on a breathtaking light show across the heavens. They serve as the universe's most important factories, forging heavy elements like gold, silver, and iron that simply couldn't exist otherwise. As we journey through the fascinating world of supernovas together, you'll discover the profound connection between these distant stellar catastrophes and your everyday existence. The calcium in your bones, the iron in your blood, and countless other elements in your body were once created in the heart of an exploding star billions of years ago. We are, quite literally, made of stardust, the legacy of ancient supernovas scattered throughout the cosmos. So join me as we explore these cosmic powerhouses that have shaped our universe and made our existence possible. We'll uncover the different types of supernovas, how astronomers detect them, and what they can teach us about the past and future of our universe. So what exactly is a supernova? In the simplest terms, a supernova occurs when a massive star reaches the end of its life in the most spectacular way possible, through an explosive death that echoes across the cosmos. This isn't just any explosion. It's the most energetic event that can happen to a single star in our universe. Imagine the energy output of our sun throughout its entire lifetime, roughly 10 billion years of constant nuclear fusion. Now, try to comprehend that a supernova releases more energy than that in just a few seconds. It's truly mind-boggling. Ancient astronomers who witnessed these events believed they were witnessing the birth of new stars, not deaths, which is why they called them novae, or new stars. It wasn't until the 20th century that we truly began to understand what these cosmic explosions actually were. Supernovas come in two main varieties, each with its own fascinating story. The first type, called core collapse supernovas, or Type 2, happens when extremely massive stars, at least 8 times the mass of our sun, exhaust their nuclear fuel. When a star can no longer maintain the delicate balance between gravity pulling inward and fusion pushing outward, catastrophe ensues. The core collapses under its own weight, triggering a massive explosion that tears the star apart. The second type, known as Type 1a supernovas, tells a different story, one of stellar partnerships gone wrong. These occur in binary star systems where a white dwarf, the dense remnant of a star like our sun, steals material from its companion star. The white dwarf grows greedier and greedier, accumulating mass until it reaches a critical threshold. Once it gains too much weight, it experiences a runaway nuclear reaction that completely obliterates the star in a cosmic detonation. Perhaps most astonishing is the temperature reached during these events. At the center of a supernova explosion, temperatures can soar to 100 billion degrees Celsius. That's about 10,000 times hotter than the core of our sun. At such extreme temperatures, atomic nuclei are smashed together with incredible force, forging new and heavier elements in the process. The first well-documented supernova in human history was observed by Chinese astronomers in the year 1054. They meticulously recorded a guest star that appeared suddenly, shining so brightly it was visible during daylight for 23 days, before gradually fading from view. What these ancient astronomers couldn't know was that they were witnessing the death throes of a massive star that had actually exploded thousands of years earlier, with its light only just reaching Earth during their lifetime. Every time you look up at the night sky, remember that you're gazing at countless stars, some of which may one day end their lives in these magnificent explosions, continuing the cycle of stellar life and death that has been occurring since the early days of our universe. The life and death of massive stars is a tale of cosmic extravagance and self-destruction. Unlike our modest sun, which patiently fuses hydrogen into helium over billions of years, massive stars live fast and die young. Think of them as cosmic rock stars, burning through their nuclear fuel at an astonishing rate, shining with incredible brilliance, only to meet a spectacular and premature end. A star with 20 times the mass of our Sun might exhaust its hydrogen fuel in just 10 million years, compared to the 10 billion-year lifespan our Sun enjoys. These stellar giants are incredibly wasteful with their resources, burning through their nuclear fuel thousands of times faster than smaller stars. This extravagant lifestyle comes at a cost. The more massive a star, the shorter its life. As these massive stars age, they transform into cosmic onions, developing layers where different elements are fused. Hydrogen burns to create helium, then helium fuses to form carbon, followed by neon, oxygen, and silicon. Each new fusion process requires more extreme temperatures and pressures, and each stage burns through fuel even faster than the last. What took millions of years with hydrogen might take just days or hours with silicon. But here's where the story takes a tragic turn. When fusion reactions in the core create iron, the star has essentially signed its own death warrant. Iron is nuclear fusion's dead end. Attempting to fuse iron actually consumes energy rather than releasing it. It's like reaching the bottom of a cosmic fuel tank with no possibility of refill. With no outward pressure from fusion to counterbalance gravity, what happens next occurs with breathtaking speed. The star's core collapses catastrophically, shrinking from roughly 5,000 miles across to just 30 miles in less than a quarter of a second. This is one of the fastest collapses known in nature. If you could somehow watch it happen, the core would seem to simply vanish before your eyes. This rapid implosion creates conditions more extreme than anywhere else in the universe except black holes. The core becomes so compressed that protons and electrons are squeezed together to form neutrons. It's as if the entire core of the star transforms into a single atomic nucleus, incredibly dense and unyielding. When the infalling material hits this impossibly hard neutron core, it bounces back with tremendous force, creating a shockwave of unimaginable power. This shockwave, traveling at tens of thousands of miles per second, races outward through the star's outer layers. Superheated by neutrinos streaming from the collapsing core, this shockwave tears through the star, blasting its outer layers into space in a cataclysmic explosion. The famous astronomer Carl Sagan once described this process as stellar alchemy, the transformation of simple elements into complex ones through the violent death of stars. Ancient cultures across the world recorded these rare visible supernovas as omens or celestial messages. When Tycho Brahe observed a supernova in 1572, it fundamentally challenged the Aristotelian belief that the heavens were perfect and unchanging, helping to usher in a scientific revolution. In the aftermath of this violence, something beautiful emerges, a rapidly expanding cloud of gas and newly formed elements that will eventually contribute to new stars, planets, and perhaps even life itself. This is how the universe recycles its materials, transforming death into the possibility of new creation. Every atom in your body has a story to tell, and for the heaviest elements, that story begins in the heart of an exploding star. Supernovas aren't just destructive forces. They're cosmic forges, the universe's most efficient factories for creating heavy elements. Without these stellar explosions, our universe would be a much simpler place, composed almost entirely of hydrogen and helium, with just traces of lithium and beryllium created shortly after the Big Bang. The process that creates these elements is called nucleosynthesis, and it's truly one of nature's most remarkable phenomena. In the final moments of a supernova, as the shock wave tears through the star's outer layers, temperatures reach billions of degrees, and pressures become unimaginable. Under these extreme conditions, atomic nuclei that would normally repel each other are forced together, creating heavier and heavier elements in a cosmic game of atomic construction. Iron represents a pivotal point in stellar nucleosynthesis. While elements up to iron can be created during the normal life of massive stars, elements heavier than iron require the extraordinary conditions found only in supernovas. In less than a second, the rapid capture of neutrons during the explosion creates dozens of elements that couldn't exist otherwise. Take a moment to look at a piece of gold jewelry if you have one nearby. That gold atom had to be created in a supernova explosion billions of years ago. The same is true for silver in your silverware, the lead in old plumbing, and the uranium that powers nuclear plants. Even the copper in your electrical wires and the zinc in your multivitamins were forged in these stellar explosions. Perhaps most remarkable is the deep connection between supernovas and our physical bodies. Every single atom of calcium in your bones was created in the heart of an exploding star long before our solar system formed. The iron in your blood that carries oxygen throughout your body? Also, a gift from ancient supernovas. The iodine in your thyroid, the potassium in your muscles, the zinc in your immune system. All of these essential elements exist because stars lived and died explosively billions of years ago. There's something profoundly moving about this cosmic connection. The 19th century scientist William Crookes once wrote that the elements are not of yesterday. They existed before the earliest dawn of history. We now know just how right he was. These elements have journeyed across vast distances and incomprehensible timescales to become part of us. When astronomers in the 1700s began to study the spectra of light from distant stars, they were shocked to find the same elements on Earth existed throughout the cosmos. This discovery sparked the realization that we're made of the same stuff as stars. But it wasn't until the 20th century that we began to understand that many of these elements originated specifically in supernovas. If you're enjoying this journey through the cosmic forges of the universe, please take a moment to like this video and subscribe to the Exploring the Universe channel. And I'd love to hear from you in the comments. Which chemical element in your body do you find most fascinating to know was created in a supernova? Is it the iron in your blood, the calcium in your bones, or perhaps something else? Share your thoughts below. And don't forget to subscribe to Exploring the Universe to continue our cosmic adventure together. This intimate connection between supernovas and ourselves is perhaps the most profound revelation of modern astronomy. We are, quite literally, made of stardust. When you look up at the night sky, you're not just gazing at distant relatives, you're looking at the very factories that created the elements necessary for your existence. Throughout human history, our ancestors looked up at the seemingly unchanging canvas of stars with a sense of permanence. The stars were eternal, immutable fixtures in the heavens, or so they thought. This perception of an unchanging cosmos was dramatically shattered on a crisp November evening in 1572, when Danish astronomer Tycho Brahe spotted something extraordinary in the constellation Cassiopeia, a new star shining with brilliant intensity where none had been visible before. Tycho's meticulous observations of this sudden celestial visitor, what we now call Tycho's supernova, sparked nothing short of a scientific revolution. In an age when Aristotelian philosophy held that the heavens were perfect and unchangeable, here was undeniable proof that the cosmos was dynamic and evolving. Tycho wrote with astonishment, "I was so astonished at this sight that I was not ashamed to doubt the trustworthiness of my own eyes." His detailed measurements proved this new star was far beyond the moon, firmly placing it in the realm of the fixed stars that were supposed to be eternal. The impact of this discovery cannot be overstated. It helped dismantle the ancient cosmological model that had dominated Western thought for nearly 2,000 years. This wasn't the first supernova observed by humans. Chinese astronomers had recorded similar events centuries earlier, but it was the one that fundamentally changed our understanding of the universe. Fast forward to more recent history, and we encounter another milestone in supernova observation. On February 23, 1987, astronomers witnessed something they had been waiting generations to see: a naked-eye visible supernova in our cosmic neighborhood. This explosion, designated Supernova 1987A, or simply SN 1987A, occurred in the Large Magellanic Cloud, a satellite galaxy of our Milky Way. What made SN 1987A so revolutionary was that it was the first supernova observed with modern astronomical equipment. When the light from this exploding star reached Earth, astronomers were ready with an unprecedented array of instruments. For the first time, they detected neutrinos from a supernova before its visible light reached us. Tiny subatomic particles that escape the star's core even before light can break free from the dense explosion. This confirmed key theories about the physics of stellar collapse. Ian Shelton, one of the astronomers who first spotted this supernova, recalled the moment with awe. "I knew I was looking at something that no human had seen before with modern scientific instruments." This was our first real chance to test our theories of stellar evolution and explosion. In recent decades, our ability to detect and study supernovas has undergone a revolution of its own. Space telescopes like Hubble, Chandra, and James Webb have given us unprecedented views of these cosmic explosions across multiple wavelengths of light. Ground-based observatories have developed automated systems that scan the night sky, comparing images to identify new supernovas almost as soon as their light reaches Earth. Today's supernova hunters use sophisticated computer algorithms that can sift through thousands of galaxy images each night, flagging anything that changes in brightness. When a potential supernova is detected, robotic telescopes can automatically swing into action within minutes, capturing vital early data before the explosion reaches its peak. This has allowed astronomers to catch supernovas earlier than ever before, sometimes just hours after the explosion begins. Perhaps most fascinating is the development of neutrino and gravitational wave detectors. Deep underground facilities filled with thousands of tons of purified water or liquid wait patiently for the subtle interactions of neutrinos from cosmic explosions. Meanwhile, gravitational wave observatories like LIGO can detect the ripples in space-time created when neutron stars, the remnants of some supernovas, collide. Amateur astronomers have also joined this cosmic hunt. In 1993, a Spanish music teacher named Francisco Garcia Diaz discovered a supernova using a modest telescope from his backyard. His discovery reminded the astronomical community that patient observers with modest equipment can still make meaningful contributions to our understanding of these cosmic explosions. From Tycho's naked-eye observations to today's global network of automated telescopes, our journey of understanding supernovas reflects humanity's enduring fascination with the cosmos and our ever-improving ability to unveil its secrets. Each new supernova we observe adds another piece to the puzzle of stellar evolution and the dynamic, ever-changing universe we call home. Supernovas aren't just spectacular cosmic light shows, they're fundamental architects of the universe as we know it. To truly grasp their importance, imagine our cosmos without these stellar explosions. We'd have a sterile universe dominated by hydrogen and helium, with no rocky planets, no complex chemistry, and certainly no life as we know it. Supernovas are cosmic kingmakers, setting the stage for everything that makes our universe rich and complex. Let's start with their role in creating new stars and planetary systems. When a massive star explodes, it sends an expanding shell of material racing outward at millions of miles per hour. This shell, called a supernova remnant, plows into surrounding gas clouds, compressing them and triggering the birth of new stars. It's a beautiful example of cosmic recycling, the death of one generation of stars directly triggering the birth of the next. The famous Eagle Nebula, captured in the iconic Pillars of Creation image, shows this process in action. Those majestic columns of gas are being compressed by nearby supernova shockwaves, causing them to collapse and form new stars. Astronomers estimate that without supernovas stirring the pot of interstellar gas, star formation in our galaxy would have slowed to a crawl billions of years ago. These explosions also play a crucial role in shaping the very structure of galaxies. The energy from supernovas creates enormous bubbles and cavities in the interstellar medium, sculpting the gas and dust into the intricate structures we see in spiral arms. In the early 1960s, astronomers first realized that without the energy injected by supernovas, galaxies like our Milky Way would look completely different. Their elegant spiral patterns would quickly wind up and disappear. Even more fascinating is the way supernovas distribute heavy elements throughout the cosmos. When a massive star explodes, it doesn't just create heavy elements, it hurls them into space at incredible speeds. A single supernova can scatter newly formed elements across hundreds of light years. Over billions of years, countless supernovas have seeded our galaxy with the building blocks needed to form rocky planets like Earth. This cosmic distribution system created the conditions necessary for planets like ours to form. Without supernovas, the early solar system would have lacked the heavy elements needed to form Earth's iron core, its rocky mantle, or the minerals in its crust. The gold in your jewelry traveled through the vacuum of space for billions of years after being created in a supernova explosion long before our sun was born. Perhaps most profound is the connection between supernovas and life itself. Every carbon atom in your body, the very backbone of organic molecules, was forged in the heart of a star and distributed by ancient supernovas. The same is true for the oxygen you breathe, the nitrogen in your DNA, and the phosphorus that forms part of your cell membranes. When renowned astronomer Carl Sagan famously said, "We are made of star stuff," he wasn't speaking poetically, he was stating a scientific fact. The atoms in your left hand might come from a different star than those in your right. We are walking, talking collections of elements created in stars that exploded billions of years ago. Early philosophers like Democritus in ancient Greece speculated that everything was made of indivisible atoms, but they could never have imagined that these atoms were created in cosmic explosions of unimaginable power. Not until the 20th century did scientists like Fred Hoyle and Margaret Burbidge develop the theories explaining how supernovas create and distribute elements. There's something deeply humbling about this connection. Every time you look at the night sky, you're not just gazing at distant stars, you're looking at the ancestors of the very atoms that make up your body. Supernovas don't just shape the physical structure of our universe, they've made possible the very existence of complex chemistry, planets, and life itself. In a very real sense, we owe our existence to these cosmic explosions. Without supernovas seeding the universe with heavy elements, the periodic table would be tragically short. Planets would be made almost entirely of hydrogen and helium, and the complex chemistry needed for life would be impossible. These stellar explosions aren't just part of our cosmic history, they're the reason we're here to contemplate that history at all. Supernovas aren't just spectacular cosmic light shows, they're fundamental architects of the universe as we know it. To truly grasp their importance, imagine our cosmos without these stellar explosions. We'd have a sterile universe dominated by hydrogen and helium, with no rocky planets, no complex chemistry, and certainly no life as we know it. Supernovas are cosmic kingmakers, setting the stage for everything that makes our universe rich and complex. Let's start with their role in creating new stars and planetary systems. When a massive star explodes, it sends an expanding shell of material racing outward at millions of miles per hour. This shell, called a supernova remnant, plows into surrounding gas clouds, compressing them and triggering the birth of new stars. It's a beautiful example of cosmic recycling, the death of one generation of stars directly triggering the birth of the next. The famous Eagle Nebula, captured in the iconic Pillars of Creation image, shows this process in action. Those majestic columns of gas are being compressed by nearby supernova shockwaves, causing them to collapse and form new stars. Astronomers estimate that without supernovas stirring the pot of interstellar gas, star formation in our galaxy would have slowed to a crawl billions of years ago. These explosions also play a crucial role in shaping the very structure of galaxies. The energy from supernovas creates enormous bubbles and cavities in the interstellar medium, sculpting the gas and dust into the intricate structures we see in spiral arms. In the early 1960s, astronomers first realized that without the energy injected by supernovas, galaxies like our Milky Way would look completely different. Their elegant spiral patterns would quickly wind up and disappear. Even more fascinating is the way supernovas distribute heavy elements throughout the cosmos. When a massive star explodes, it doesn't just create heavy elements, it hurls them into space at incredible speeds. A single supernova can scatter newly formed elements across hundreds of light years. Over billions of years, countless supernovas have seeded our galaxy with the building blocks needed to form rocky planets like Earth. This cosmic distribution system created the conditions necessary for planets like ours to form. Without supernovas, the early solar system would have lacked the heavy elements needed to form Earth's iron core, its rocky mantle, or the minerals in its crust. The gold in your jewelry traveled through the vacuum of space for billions of years, after being created in a supernova explosion long before our sun was born. Perhaps most profound is the connection between supernovas and life itself. Every carbon atom in your body, the very backbone of organic molecules, was forged in the heart of a star and distributed by ancient supernovas. The same is true for the oxygen you breathe, the nitrogen in your DNA, and the phosphorus that forms part of your cell membranes. When renowned astronomer Carl Sagan famously said, "We are made of star stuff," he wasn't speaking poetically. He was stating a scientific fact. The atoms in your left hand might come from a different star than those in your right. We are walking, talking collections of elements created in stars that exploded billions of years ago. Early philosophers like Democritus in ancient Greece speculated that everything was made of indivisible atoms, but they could never have imagined that these atoms were created in cosmic explosions of unimaginable power. Not until the 20th century did scientists like Fred Hoyle and Margaret Burbidge develop the theories explaining how supernovas create and distribute elements. There's something deeply humbling about this connection. Every time you look at the night sky, you're not just gazing at distant stars. You're looking at the ancestors of the very atoms that make up your body. Supernovas don't just shape the physical structure of our universe, they've made possible the very existence of complex chemistry, planets, and life itself. In a very real sense, we owe our existence to these cosmic explosions. Without supernovas seeding the universe with heavy elements, the periodic table would be tragically short. Planets would be made almost entirely of hydrogen and helium, and the complex chemistry needed for life would be impossible. These stellar explosions aren't just part of our cosmic history, they're the reason we're here to contemplate that history at all. The scientific community has long been fascinated by the cosmic drama of supernovas, and some of the greatest minds in physics have contemplated their significance. The legendary Stephen Hawking once remarked, "Supernovas are where we all came from, the explosion of a star that scattered the elements from which you and I are made. This poignant observation encapsulates how these stellar explosions connect to our very existence. Hawking often emphasized that understanding supernovas wasn't just astronomy for astronomy's sake. It was about understanding our cosmic origins and the fundamental processes that made life possible. In his final book, Brief Answers to the Big Questions, Hawking reflected on how supernovas create the conditions for life across the universe. The heavy elements that are essential for life were created in the nuclear furnaces of stars and then scattered across space when the stars exploded. He saw supernovas as crucial links in the chain of cosmic evolution that eventually led to intelligent life pondering its own origins. Today's researchers are pushing the boundaries of supernova science in exciting new directions. Dr. Maria Rodriguez from the California Institute of Technology leads a team developing what she calls early warning systems for supernovas. We're looking for subtle changes in stellar behavior that might precede an explosion, she explains. If we could detect a supernova hours or days before the visible explosion, it would revolutionize our understanding of stellar death. This early detection effort relies on neutrino detectors buried deep underground and sophisticated algorithms monitoring thousands of stars simultaneously. The Super Kamiokande detector in Japan, a massive tank containing 50,000 tons of ultra-pure water, stands ready to catch the first neutrinos from the next galactic supernova. When a star's core collapses, it releases an enormous burst of neutrinos that escape the star even before light can break free from the dense stellar material. Behind the scenes, there's a friendly but intense debate raging in the astronomical community about exactly how supernovas explode. Dr. James Latimer of Stony Brook University explains the controversy. We know the basic story. A massive star runs out of nuclear fuel, its core collapses, and then, well, that's where things get complicated. Our computer simulations still struggle to reliably produce the explosion we know must happen. This explosion problem has puzzled theorists for decades. Some researchers believe the key lies in neutrinos energizing the shockwave, while others point to rotation and magnetic fields as crucial factors. Dr. Elliot Quatiert from Princeton University adds, "It's humbling. We can observe these explosions across billions of light years, but we still can't fully explain how they work. Nature is more creative than our computer models. The question on many astronomers' minds is, when will the next supernova light up our galactic neighborhood?" Dr. Andrea Ghez, Nobel Prize-winning astronomer, offers her perspective. We're statistically overdue for a supernova in the Milky Way. There are several candidates that could go supernova at any time. Betelgeuse, Eta Carinae, and several others we're keeping a close eye on. Betelgeuse, the red supergiant star forming Orion's right shoulder, has received particular attention after its unexpected dimming in late 2019. While that specific event wasn't the prelude to an explosion many hoped for, astronomers believe Betelgeuse could still go supernova any time within the next 100,000 years. Tomorrow, or long after our civilization is gone. Dr. Robert Kirshner of Harvard University, who has spent his career studying supernovas, provides a sobering reminder. Stars operate on timescales that make human lifetimes seem insignificant. We might get lucky and witness a galactic supernova in our lifetime, or we might just be adding our brief watch to the generations of astronomers who came before and will come after. If we are fortunate enough to witness a nearby supernova, modern astronomical instruments will capture every detail in unprecedented ways. A network of telescopes stands ready to swivel automatically toward any detected explosion, while space-based observatories would provide views unobstructed by Earth's atmosphere. Perhaps most exciting is the possibility of detecting not just light, but gravitational waves from the next galactic supernova. Dr. Gabriela Gonzalez, former spokesperson for the LIGO Scientific Collaboration, explains, A nearby supernova would produce gravitational waves that could reveal what's happening at the very core of the explosion, something we simply cannot see with traditional telescopes. As our understanding of these cosmic explosions continues to evolve, one thing remains clear. Supernovas will remain at the center of astronomy's biggest questions for generations to come. From the creation of elements to the birth of neutron stars and black holes, these stellar deaths touch on nearly every aspect of cosmic evolution that makes our universe the fascinating place it is. When we gaze up at the night sky, we're not just observers of the cosmos, we're participants in its grand story. Supernovas, perhaps more than any other astronomical phenomenon, help us understand our place in this cosmic narrative. These stellar explosions have profoundly shaped how we view ourselves and our universe throughout human history. In ancient times, unexpected bright stars appearing in the heavens were often interpreted as divine messages or omens. When Chinese astronomers in the year 1054 meticulously recorded the appearance of what we now know was the supernova that created the Crab Nebula, they couldn't have known they were witnessing a process fundamental to their own existence. Similarly, when Tycho Brahe observed his famous supernova in 1572, he couldn't have realized he was looking at the very mechanism that created many of the elements in his own body. Today, our understanding of supernovas has transformed our self-perception. We now know that we are, in the most literal sense, children of the stars. The calcium in your bones, the iron in your blood, the carbon in your muscles, all were forged in stellar furnaces and scattered by ancient supernovas long before our solar system formed. This realization represents one of the most profound connections between human existence and cosmic processes ever discovered. As poet Rebecca Elson beautifully expressed it, we are the universe's way of examining itself. There's something deeply moving about the fact that atoms created in stellar explosions billions of years ago have assembled themselves into beings capable of discovering their own origins. When we study supernovas, we're essentially studying our own cosmic ancestry. These stellar explosions have also driven remarkable technological innovation. The desire to better observe and understand supernovas has pushed the boundaries of what's possible in astronomy. The first digital electronic camera was developed specifically to better capture the light from distant supernovas. The Hubble Space Telescope, one of humanity's greatest technological achievements, has spent countless hours imaging supernova remnants and distant explosions. Behind the scenes of these technological advancements are human stories of persistence and ingenuity. Take Jocelyn Bell Burnell, who as a graduate student discovered pulsars, the rapidly spinning neutron stars left behind by some supernovas. Despite making one of the most significant astronomical discoveries of the 20th century, she was initially excluded from the Nobel Prize awarded for the discovery. Her story highlights both the human drive to understand these cosmic phenomena and the all-too-human challenges in scientific recognition. The search for supernovas has also connected amateur and professional astronomers in unique ways. Robert Evans, an Australian minister, has visually discovered over 40 supernovas simply by memorizing the appearance of thousands of galaxies and noting when a new star appears. His remarkable visual memory and dedication remind us that human observers still play a crucial role alongside sophisticated technology. Looking toward the future, supernova research promises to answer some of our most fundamental questions. Next-generation observatories like the Vera Rubin Observatory will scan the entire visible sky every few nights, potentially discovering thousands of supernovas annually. Meanwhile, neutrino detectors buried deep underground stand, ready to capture the invisible particles that herald a stellar collapse. Perhaps most exciting is how supernova research intersects with the search for life beyond Earth. By studying which types of stars go supernova and how frequently, Astronomers can map out habitable zones, not just around individual stars, but throughout entire galaxies. Some regions of galaxies may be too frequently sterilized by nearby supernovas to allow complex life to develop, while others might provide the perfect balance. Enough supernovas to create heavy elements, but not so many as to pose a constant threat. As we push forward into the 21st century, supernovas will continue to illuminate our cosmic perspective. They remind us that destruction and creation are intertwined, that endings make new beginnings possible. In a universe that often seems indifferent to human concerns, supernovas provide a surprising connection. The spectacular deaths of stars made our lives possible. When you next look up at the night sky, remember that you're not just made of stardust, you're made of supernova dust. Your very atoms were forged in the most energetic events since the Big Bang. And now, those atoms have assembled themselves into a consciousness capable of appreciating the beauty and wonder of the very process that created them. This is perhaps the most profound gift supernovas have given us. Not just the elements of our bodies, but a deeper understanding of our place in the cosmic story. As we reach the end of our cosmic journey today, I want you to pause and really think about what we've discovered. Supernovas aren't just spectacular light shows in the distant universe. They are the very cosmic furnaces that created the chemical complexity necessary for our existence. Look at your hand for a moment. The iron flowing through your veins, carrying oxygen to every cell in your body. It was forged in the heart of an exploding star billions of years ago. That gold wedding ring or piece of jewelry you might be wearing, it tells the story of an ancient stellar explosion where temperatures reached unimaginable heights. Every calcium atom in your bones, every trace of silver, platinum, and uranium on our planet, all these elements have traveled an incredible journey from the core of a dying star to become part of our world, our bodies, our lives. When poets and philosophers say we are stardust, this isn't just beautiful metaphor, it's literal scientific truth. We are, in the most real sense, children of the stars. The next time you gaze up at the night sky, remember that you're not just looking at distant points of light, you're looking at the ancestors of the very matter that makes you, you. Isn't that something truly worth contemplating? If you've enjoyed this cosmic perspective on supernovas, please help our channel continue exploring these wonders of the universe. Hit that subscribe button on Exploring the Universe. Turn on notifications so you never miss an upload. Drop a like on this video and share it with friends who might appreciate this cosmic connection.